Welcome to the debate. Think about an avalanche for a second. To the observer standing down in the valley, an avalanche seems completely binary.
Right.
1 minute, the mountain looks perfectly stable, solid stone and packed powder. And the next minute, a microfracture connects with another, and the entire face of the mountain gives away. To the naked eye, it's just sudden, catastrophic motion out of nowhere.
Yeah, it feels like it happens without a single warning sign. Just total collapse.
Exactly. But the reality is that the math of the snowpack was changing invisibly for weeks. The temperature gradients, the structural pressure, all of it. The threshold for collapse was crossed long before a single snowflake actually moved.
Which is a terrifying thought, but very apt.
Right. And that dynamic is exactly what we are exploring today. Grounded in Dr. Jonathan H. Westover's research framework, specifically, when will AI replace you? A strategic framework for human-AI workforce transitions. What makes this research so compelling is that it completely ignores standard technological forecasting.
We aren't just looking at what AI can do.
Exactly. We are looking at the invisible organizational math, the pressures building under the snowpack of the modern workforce. The core question is this: does the mathematical reality of risk-adjusted costs ultimately dictate that AI will replace humans, or do things like organizational friction, psychological barriers, and regulatory stickiness fundamentally constrain that economic determinism?
And it is a massive question.
It really is. And my view on this is that the math is undeniable. When the risk-adjusted cost of an AI crosses a specific threshold, substitution isn't a gradual fade. It's an inevitable, sudden event that just rewrites the organizational chart. The friction you see in companies today is just a temporary delay tactic against mathematical certainty.
Well, I argue those delay tactics are actually profound structural barriers. We're talking about psychological costs, complex risk governance, and the deep need for institutional legitimacy. These aren't just minor variables you can tweak in an economic formula. They fundamentally alter, and in many cases, indefinitely delay, this idea of pure automated economic substitution.
Okay, let's get right into the mechanics of that formula then, because my entire argument rests on what the research calls the human-AI substitution principle. The underlying logic here is actually incredibly elegant.
It is elegant on paper, I will give you that.
Right, so substitution happens when, and only when, an AI agent offers a lower risk-adjusted effective cost for a specific task, period. It's economically determined. But what people miss is the threshold substitution rule.
Which means what, practically?
It means we need to stop thinking about AI taking over jobs like water eroding a rock over decades. The math shows it's discontinuous. When the cost difference crosses zero, the allocation just flips. One day a human does the task, the next day an algorithm does.
On paper, yes. The math flips.
But it's not just on paper, it's driven by undeniable scaling laws. Think about human labor. Human wages rise exponentially over time. As workers gain skill, tenure, experience, they cost the company more.
Sure.
But AI capability costs scale weekly. Once a massive model is trained, the marginal cost to run that model, what we call inference, is incredibly cheap. So you have exponential human costs colliding with flat marginal AI costs. The economic pressure of that delta makes the avalanche inevitable.
I hear the elegance of that, I really do, but you are leaning incredibly hard on the cost part of the equation in treating the risk part as an afterthought.
I wouldn't say an afterthought.
Well, that risk-adjusted cost equation has a massive institutional bottleneck hidden inside it. The framework decomposes this risk into 3 parts. You have reliability, compliance, and reputation. You can't just hand-wave these away as minor mathematical penalties that a cheap server can overcome.
I don't think they are minor. I just think they are quantifiable.
But they carry massive psychological and institutional weight. Look at the human element. There is a well-documented phenomenon known as algorithm aversion. When an AI makes a mistake, humans lose trust in it far faster than they do when a human makes the exact same mistake.
Right. We hold machines to a higher standard.
Exactly. We struggle to calibrate our trust with machines. And when you look at institutional theory, it's clear that firms cannot optimize purely for efficiency without facing intense normative backlash. If a hospital or a bank strips out the human element just to save a few basis points on task execution, they lose their organizational purpose. They lose their institutional legitimacy in the eyes of the public and the regulators. That fundamentally blocks the substitution you claim is inevitable.
Marginally more accurate than a human worker, they literally won't deploy it because the social and legal need for a human scapegoat overrides the math?
I'm saying the company literally cannot deploy it without incurring new, massive, unquantifiable risks. The math of the task might work, but the math of the organization's survival in a highly regulated society breaks down.
Okay, but let's look at how that actually plays out in the real world, specifically in the corporate hierarchy, because the research points to a fascinating phenomenon called a single crossing pattern.
Ah, yes, the vulnerability of middle management.
Exactly. Let me break this down. If you plot management compensation on a graph, the line goes up as you move from junior managers to middle managers to executives.
Obviously.
Right. But the cost of AI stays relatively flat across those cognitive tasks. So those two lines cross right in the middle. Cost-based substitution pressure rises sharply for middle managers because they are expensive, but they don't yet have the massive top-level accountability and strategic requirements of a CEO.
The executives are protected by the sheer complexity of their decisions.
Exactly. But the middle layers, the people doing routine coordination, exception routing, synthesizing reports from 5 departments into one memo, the economic pressure there is tectonic.
I see where you're going with the geology analogy again.
Well, think about structural geology. The pressure builds invisibly on those middle layers of rock until the fault line suddenly snaps. That's the discontinuous threshold, and the data backs this up. Recent workforce analytics from firms adopting AI showed disproportionate, heavy reductions specifically in middle management positions. It's not a theory about the future. The fault line is snapping right now.
You're completely right about the vulnerability of coordination tasks, but I think you're misinterpreting what happens to the organization afterward.
How so?
Your geological analogy assumes that if AI can do the routine, scheduling, and reporting, the middle layer just evaporates into thin air and the company runs perfectly.
Let's look at the mechanics of organizational design. If you eliminate those middle layers, you have to widen the span of control for the managers who are left.
Right. A director who used to manage 5 middle managers now directly oversees 20 frontline employees, relying on an AI dashboard to track them.
Right, which is a massive efficiency gain.
But it structurally breaks down without profound human contextual understanding. There is a concept in algorithmic system design called contestability.
Contestability.
Yes. It means that when an AI system flags an anomaly, say a sudden drop in a salesperson's performance, there must be a human mechanism to contest, investigate, and contextualize that flag. You need distributed leadership, not just automated reporting. So middle management isn't eliminated, it's redefined. The role shifts from routine data collection to exception handling, strategic translation, and resolving the messy political realities of human employees. The AI points out the problem, but the human middle manager actually solves it.
I understand the desire to frame it as a redefinition, but let's be intellectually honest here. When a company redefines old through automation, it usually means they are eliminating 3 jobs to create 1 new one.
Fair point.
The mathematical reality is that the depth of the organizational chart is shrinking. And what is most fascinating about this, and frankly counterintuitive to decades of labor economics, is the skill paradox.
The exposure of the highly educated worker.
Yes. For decades, the assumption was that automation was coming for the factory floor. But there's this great irony in AI, widely known as Moravec's paradox. It is incredibly easy to train a massive neural network to pass the bar exam or pass a medical licensing test. But it is almost impossible to train a robot to reliably fold a towel, clean a hotel room, or frame a house.
Right. The physical world is messy.
So the blue-collar manual labor is completely protected by the sheer physical complexity of the real world. But the financial analyst, the mid-level corporate lawyer, the middle manager, they are directly in the vulnerability zone because their outputs are purely linguistic and analytical. AI capability can replicate those exact cognitive outputs at a near constant cost, while human wages in those high-skill sectors grow exponentially.
I don't disagree that high-skill cognitive tasks are technically exposed.
The large language models are undeniably proficient at linguistic synthesis, but technical capability is not the same as organizational deployment.
Why wouldn't it be, if it can do the job?
The assumption that just because an LLM can write a flawless legal brief, it will seamlessly replace a law firm's paralegal team completely ignores the compliance and reputational risk weightings. Let's look at cross-industry adoption rates. Have you noticed why healthcare and legal services lag far behind software development and marketing in AI deployment?
I mean, because they are historically conservative industries.
No, because of domain-specific risk weightings. In the analytical model we are discussing, there is a variable for the risk penalty. Let's call it the institutional penalty. In software coding, if an AI hallucinates a line of code, the compiler catches it, or it creates a bug that a human fixes.
The penalty is low.
Exactly. But in healthcare, if an AI hallucinates on a medical chart, the penalty is a massive malpractice lawsuit and FDA intervention. Look at how major banks like JP Morgan Chase have handled this. They didn't just fire their analysts and plug in an LLM.
They built an entire infrastructure around it.
Yes, an entire centralized model risk management function. Their aggressive AI adoption was only possible by building massive compliance infrastructure, adversarial testing teams, and human-in-the-loop override mechanisms for high-stakes decisions. The human wasn't replaced by the AI. The human was retained as an institutional hedge against the AI's risk.
You're entirely right about the compliance piece. But I think you're underestimating the sheer force of the economics here. You are treating that compliance risk like a permanent, static brick wall.
It largely is in those sectors.
But in reality, risk mitigation is just an engineering problem, and engineering problems scale. The JP Morgan example actually proves my point beautifully. Yes, they had to build a massive, expensive compliance infrastructure, but once they built it, they were able to amortize that fixed cost across their entire global operation.
But that takes enormous capital. Not every firm can do that.
Exactly. Large firms amortize these massive training and governance costs across multiple divisions, which drives the per-task inference cost to near zero. Think about how Salesforce deploys its Einstein AI platform. They embed predictive lead scoring, automated routing, and sentiment analysis across tens of thousands of enterprise clients.
Right.
The fixed cost of development, risk proofing, and compliance is spread over a colossal user base. That means the AI cost per customer absolutely plummets. This is what we call deployment scale acceleration. It creates an unstoppable first-mover advantage. The scale amortizes the risk penalty, pushing the risk-adjusted cost gap below zero much faster than smaller firms can react. It forms a structural competitive moat that guarantees substitution.
That is a compelling explanation of the economics of software, but I think you're conflating computing scale with trust scale.
How so?
The moat you are describing isn't just about spreading server costs over 1 million users. It is the ability to absorb institutional risk penalties, which naturally slows down pure economic substitution. You simply cannot scale trust the way you scale server compute.
Why not? If the system is proven mathematically reliable across 1 million iterations, the trust is inherent in the data.
Because society doesn't regulate based on pure statistical reliability, it regulates based on accountability. Let's go back to healthcare and legal services. The regulatory bodies in those fields mandate structural human oversight. So yes, Salesforce can scale lead scoring infinitely because a false positive on a sales lead doesn't trigger a federal investigation or ruin a patient's life.
Right. The stakes are lower.
But a hallucination in a medical diagnosis or a regulatory filing does. The risk penalty exceeds the cost advantage. Therefore, the hybrid structure where humans remain fundamentally in the loop to absorb liability and provide normative legitimacy is not a temporary friction. It persists organically. It's an equilibrium.
But even if we assume that equilibrium exists, human adaptation is already shifting toward it, and workers are doing it rationally based on the math.
What do you mean?
Well, the framework calls this the strategic substitution equilibrium. Workers aren't just sitting still like deer in the headlights waiting for the avalanche to hit. They're actively mapping the terrain and endogenously investing in upskilling. They are migrating specifically to what the research calls the contested zone, the areas where human-AI collaboration is still viable and the cost threshold hasn't crossed zero.
That requires an enormous amount of foresight from the average worker.
It does, which is why organizations are actively subsidizing it. Look at AT&T. They faced massive automation-driven displacement in their network operations a few years ago. The math was clear. The machines were going to do the routing. But AT&T didn't just fire everyone.
They retrained them.
Right. They invested over $1 billion in a massive employee retraining initiative. And they didn't train people randomly. They explicitly targeted roles where automation had not yet crossed the substitution threshold, domains requiring deep human-to-human empathy, complex problem-solving, and AI oversight.
Okay.
And it worked. 5 years post-launch, internal mobility rates among those participants exceeded 50%. This proves that humans respond rationally to the risk-adjusted cost math. They move their skills up the curve to stay just ahead of the capability line. It's a managed economic transition.
I look at that exact same transition, and I see a deeply traumatic disruption of the modern workforce. Applying pure rational economic framing to human livelihoods completely misses the profound psychological weight of what is happening. What you are calmly describing as a rational shift to the contested zone is, on the ground, a severe erosion of the psychological contract between firms and employees.
The psychological contract being the unspoken expectation of loyalty?
Exactly. For generations, traditional employment implied long-term job security in exchange for loyalty and incremental skill development. You put in the time, you get the security. This AI transition violently disrupts that compact. It shifts the promise from employment security to merely employability security.
Which is a big shift, yes.
Think about the psychological impact of telling a worker with 20 years of exemplary performance that their accumulated expertise is suddenly mathematically obsolete, and their only hope of survival is to constantly outtrain an exponentially improving algorithm. It is deeply destabilizing. It triggers what researchers call identity threat.
I completely understand why that feels destabilizing. It is a harsh reality. But isn't that exactly why transparency is the most crucial tool an organization has right now?
Transparency doesn't soften the blow of losing your livelihood.
But Dr. Westover's framework suggests organizations should actively use substitution dashboards and threshold-based workforce planning. Instead of hiding the ball in the C-suite and making automation look like arbitrary, cruel layoffs, you actually show the workforce the math. You map the skill zones openly.
I'm skeptical that helps.
You sit down and say, here is the protection zone, where human skills are irreplaceable, and here's the vulnerability zone, where the cost curve is crossing zero. By making the criteria transparent, you actually reduce that algorithm aversion we talked about earlier. Workers understand that substitution reflects objective economic thresholds, not a personal failure on their part. Major consulting firms are doing exactly this with scenario-based modeling to move companies from chaotic layoffs to proactive reallocation.
I'm sorry, but I find that incredibly naive about human nature. Showing an employee a glowing digital dashboard that mathematically proves they are about to be replaced does not preserve their sense of organizational purpose. Institutional theory tells us that an employer viewed as indifferent to worker welfare suffers massive reputational damage and long-term talent acquisition difficulties.
If they do it poorly, sure.
If you frame AI purely as a cost reduction mechanism, a race to a mathematical zero, you destroy the workforce's sense of belonging. Research clearly shows that if firms don't deliberately design AI to create new human-centric tasks, they will face massive talent attrition and passive resistance.
Meaning they sabotage the deployment?
Exactly. If the narrative in the office is replacement, you trigger that identity threat. Workers will drag their feet, they will highlight every single error the AI makes, and they will refuse to train the models. If the narrative is augmentation, you might succeed.
Right.
But augmentation means designing the system specifically to keep humans central to the workflow. And that deliberate design choice prevents the full, discontinuous economic substitution you are arguing for. The math might work perfectly on a server, but human resentment and loss of purpose can entirely sabotage the deployment in the real world.
That's a fascinating look at the internal politics. But let me push back on the idea that resentment can stop the economic gravity. Identity threat, passive resistance, loss of purpose, these are variables, certainly, but they are not insurmountable walls. We have to look at market competition. Let's say firm A refuses to fully deploy an AI system out of a noble desire to preserve traditional job identities and avoid upsetting its workforce.
Okay.
But firm B fully commits and drops the cost of a routine cognitive task by 90%. Firm A will simply be outcompeted and driven into bankruptcy. The market does not care about the psychological contract if the competitor's product is dramatically cheaper and faster.
But you are assuming Firm B's product is actually identical in quality, which ignores the risk of removing the human.
Let me finish the economic mechanism here, because the framework actually addresses this through the perturbation stability theorem. I know that sounds incredibly dense, but the concept is vital.
Go on.
The theorem mathematically proves that small, incremental changes in cost or technology leave an organization's structure mostly unchanged. People adapt, they tweak workflows, but once that specific threshold is crossed, once the AI is definitively cheaper and sufficiently reliable, the optimal workforce composition has to change discontinuously. It's not a choice anymore. Firms will adapt to the math, manage the transition costs of retraining, or they will cease to exist.
You are assuming the math always resolves in favor of the algorithm, and that simply isn't true for high-stakes, professional environments. Think about the system of professions in our society. Domains protected by licensing, ethics boards, and normative legitimacy rely on jurisdictional persistence.
Sure, lawyers, doctors.
Exactly. The tasks that complement the AI managing the terrified client, applying ethical judgment, interpreting gray areas of regulation, these carry massive risk penalties if handed over to an algorithm. And this brings us right back to the absolute core of our disagreement. You view these compliance hurdles, reputational weights, and psychological barriers as transition friction, a temporary speed bump on the way to total automation. I view them as permanent features of the organizational terrain.
You see them as the bedrock.
Precisely. The theoretical cost thresholds provide a highly useful map of where the technology is going, but the actual terrain of human transition is dominated by risk governance and the psychological weight of redefining what work even means. The friction is a feature, not a bug. It ensures that hybrid organizations where humans and AI work in tandem will persist long into the future, precisely because humans are legally and socially required to absorb the risks that algorithms cannot hold.
Well, while risk and friction certainly exist, and you've made a brilliant case for how heavy they can be, I still argue they merely adjust the variables in the equation. They don't rewrite the fundamental laws of organizational economics. Risk governance, compliance infrastructure, and even psychological resistance are ultimately measurable, amortizable costs. When the risk-adjusted cost gap hits zero, whether that happens through AI capability improvements, falling computing costs, or large-scale risk mitigation engineering by giants like Salesforce, the phase transition of substitution is sudden and inevitable. It will structurally flatten organizations and heavily reward those that know how to scale.
We may never agree on whether the math or the friction ultimately wins out, but I think where we absolutely do converge is on the total inadequacy of just looking at technology in a vacuum. Both of us agree that technical capability, the mere fact that a large language model can write a script or parse a contract or analyze a data set, is an entirely insufficient metric for predicting actual job loss.
Absolutely. That is the genius of Westover's framework. The true battleground isn't in the computer science lab evaluating benchmark scores. It is deeply embedded in risk-adjusted organizational economics.
Exactly. And the exact timing of when AI will replace specific roles remains a highly dynamic, incredible tension. It is a constant daily push and pull between the dropping costs of inference and those stubborn, deeply human risk factors. It requires organizations to constantly balance brutal efficiency with institutional accountability.
Which leaves us all with a profound question to examine within our own industries and our own careers. If we look closely at the risk-adjusted cost gap in our daily tasks, we have to ask ourselves, do we sit safely in the protection zone, anchored by physical complexity and human empathy, or are we drifting invisibly into the vulnerability zone? There is so much more to explore within Dr. Westover's framework. But it brings us right back to that mountain.
The avalanche.
Right. The snowpack looks perfectly stable today. The surface is calm, but the mathematical pressure is building relentlessly beneath the surface. The question isn't if the threshold exists, but when it will snap.